Hey guys, welcome. This is our project on Python data visualization on relation between crop price and quantity of pesticide, herbicide, and fungicide used. So these are our team members. This is a brief problem statement that we have. We want to predict the price of each of the 5 identified crops based on factors of type of chemical used and each type different quantity of chemical used. Here's a breakdown. So first of all, we need to know what data we're using, how we prepare the data, how we improve on the models, and then discussion analysis. Yeah, so these are data that we use. These are crop price. Then we have quantity of different pesticide use, price of the pesticide, herbicide, fungicide, etc. Then to improve on the model, afterwards we added 2 more data sets on agricultural expense as well as world population. Right. So let's take a look at the model on our Jupyter notebook. Right, so this is our Jupyter notebook. So these are our dependent variable, which is price of crop. That's what we are predicting. The predicted variables that we use is quantity of pesticides, herbicide, and fungicide, and as well as the prices of these. And then we imported relevant libraries like NumPy pandas for data visualization. These are for plotting the graph. So first, our data set is include a lot of irrelevant data as well as wrong formatting. So what we did. We slice the data into only relevant columns, and then with this function we return mp.nen for non-numbered values, and then to remove comma in numbers. And then with this function we returned integer value for years because the years apparently are in .0 format. And then to clean the data, we remove duplicated data, duplicated years, and then you use this for loop. We took an average of all the data with the same year, and then return just one. So we plotted and we merged all the data together, and then this returns us this with still a lot of missing data shown by this NaN thing. So we have no choice, unfortunately, because the data set is incomplete. So we plotted this graph with a linear graph in Excel, and then derived values for the missing years in between, and then we export and import the value again. This gives us fill up the missing data. So we built our model based on multiple linear regression. Yeah, so these are the things, some of the codes that we borrow from cohort practices. These to prepare, split data, normalize, and then calculate, predict R square, etc. So we build the data, and this shows that this gives us coefficient here, and visualize our predicted values and extra price. So to evaluate our R square, to evaluate the model, we decided to put in adjusted R square because it is more able to determine the relevancy of each predicted value. If we remove or add in ones, it can better reflect adjusted R square based on that. This is to build our model again. So now we reflect adjust the R square value in the axis, and then if the values are negative is bad, positive is good. So yeah, out of 5 models, 4 are bad. So this means that our models have issue. So we decided to improve our model to try and remove variables to see if it's relevant. If the adjusted R square is more positive, then it's good. So we did this again. Some values improved, while some values so it's not very conclusive. It is probably because we have a lot of missing. We have a lot of missing omitted variable that we believe that might be relevant. As you can see, price of crop may not be just attributed to quantity or price of the pesticides, herbicides we used. So we decided to add in a lot of relevant demand factors as well as supply factors that is able to influence price. So that's what we did for iteration 2. So we added in 3 main predictive variables. Global population, this would reflect the well-balanced local and global demand for US crops. Then we added in operational costs of agriculture across US. This would be a supply factor that influences the supply of crop. And then we added in one more demand factor, consumption per capita in US. And then so we added in these data sets and cleaned them and added them again into the huge data set. So this gives us new plots and new data. And then what is our conclusion? Well, this time our adjusted R-square is mostly positive for each crop except for corn, which is special, but ultimately it's much better, and we are able to get a great plot, great model out of this. So why is our prediction for corn bad? It could be that there's omitted variable for corn model, as corn is used largely for livestock and biofuel production in the US, and it is not reflected in our model. So perhaps if we added in more demand factors that predicts that, we're able to get a better model. And then of course, another factor that influenced our accuracy of our model is that the missing data sets that we had. So there was a lot of missing data, and we did logical guessing to predict it, which is still not very good. Could result in a lot of inaccuracy. And then the adjusted R-square value, it shows that some price of crop could be more dependent on quantity of chemicals, some are more dependent on the demand and supply factor. So it ultimately shows based on the estimated value that we have, the beta values of each predicted estimator. Alright, so this is our conclusion. Thank you very much.